Hi, I'm Humphrey Blackburn, and welcome to Blue Future Filters. I already knew a fair amount about water and water treatment when I started grad school in 1989. I got into a pretty unique engineering program at Humboldt State called International Development Technology, and a lot of people that were in that program were Peace Corps people. And so I really learned in that year or 2 years that I was in that about, besides water testing, water engineering issues, but also I learned a lot about what makes projects sustainable and what makes them fail. Because places like Africa are filled with well-intentioned, well-meaning, expensive water treatment projects that failed because they didn't have the support one way or another. Either there was no technical support locally, there was no money locally, they required chemicals that couldn't be found locally. Those kinds of issues. We have sound designs that we've used for 20 years now, and we build those to those, and sometimes we tweak them, sometimes we change them, but anytime somebody buys one of our filters, it's based on 20 years experience with that design. And that brings the cost down and makes it reliable and makes it easy to plug in, because people just need to tell us how much water they need, and we just provide it at that size, the size that we have that fits that. So sustainability for us in a technology choice is extremely important, and sustainability doesn't just mean something that can be operated for a long time. It means that it can be operated in an appropriate manner to the people who are going to be using it and maintaining it. And that means that there has to be the kind of, before you even choose a technology, you have to look at the community of the people who are going to be using it and maintaining it to see what sort of resources they have. Do they have electricity? Do they have the ability to store and maintain chemicals if that's required for your system? If there are people who can actually do the work, who have the skill. And you'd be surprised, but that excludes probably 90% of water treatment technologies. That right there. If you go into some place in the Amazon, or if you go to some place in Central Africa, most of the technologies that we take for granted here in the West are pretty much useless. The international experience that we have translates very well to developing countries, developed countries too. For instance, the United States and Europe, where there's a lot of rural communities who don't have the means to operate or maintain sophisticated systems, sophisticated water treatment systems. So they can use ours, and which is one of the reasons why the EPA, the U.S. EPA, has identified slow sand filtration as one of the 4 approved technologies, because it totally fits with a lot of rural communities, state parks, national parks, small communities, trailer parks, a lot of rural applications in the U.S.
I'm Peter Blackburn, Vice President for Operations at Blue Future Filters. And I'm standing here in front of one of our SSF-10 slow sand filtration units being used to treat rainwater, in this case, to drinking water standards. And one of the big challenges with the water crisis, of course, is having enough accessible, usable water. And one of the solutions is, of course, rainwater treatment. And so that's what we're doing right here, making that accessible. What's great about this system is that it's replacing what would otherwise be a highly engineered system with a long lead time for any community that wants to implement water treatment. And that's true in the United States and Australia, as true as it is in Thailand, where we've worked, or Indonesia, or in Latin America. And that's because we approach it as an original equipment manufacturer with partnerships with local manufacturers who can, for example, provide our highly shippable water treatment tanks and some of the specialized plumbing components that we use.
When we're trying to find a solution to a specific water treatment problem, we do a fair amount of research and development to test out our ideas and to find the best solutions. So in this case, that's exactly what we're doing here. This is a test gray water treatment system and water reuse system that we've developed here.
Our aeration system is actually powered with a very compact solar unit. And increasingly that's a component in sustainability from our perspective, is using readily available power, that where you won't have to tap into the grid.
So we have slow sand filters, 6 basic models in poly tanks, a 450 gallon a day, 1800, and then 1.25 GPM, 3 GPM, 6 GPM, and 10 GPM slow sand filters. For iron filters in the poly series, we have a small one in FEX, which will do about 1800 a day. The ME4, which is a residential one also, but it'll do about 5,000 gallons a day. And then the 2 larger, more commercial units, the ME25 and the ME50, which do 25 GPM and 50 GPM respectively. We have roughing filters, which are pre-treatment, basically for the slow sand filters, for anybody that wants to really take down algae and turbidity and that kind of thing. We have an RFX and an RF1 and an RF25. The RFX does about 1,000 gallons a day. The 1 does about 1,800. The 25 does about 25 GPM. And then we have a small rainwater filter, which just takes water from the gutters and treats it in a cursory way before treatment from a slow sand filter. And then we have the reflex series of filters, which are the geomembrane based filters, which we can ship anywhere. They come in a box and you basically unfold them and fill them with media and they're ready to go. And then the large steel tank systems, of which we have slow sand filters up to 1,000 GPM and iron filters in high volumes, and some specialized filters like the ones that we have done for coal bed methane treatment, which are basically our iron filter with some added features. This is a 200 gallon per minute slow sand filter that we designed and is now installed in Kenwood, Oklahoma. Looking down from above, you can see the sand in the filter. That center pipe coming up in the middle there is for cleaning purposes. And you can see the sand, media, and then in the upper part is the inlet structure. So the water comes in through that pipe and splashes on that concrete block, so it doesn't just dig a hole in the sand. And looking up, we're going to come across over to the weir tank, which controls the flow for the filter. And back around to the front so we can see the valving controls the water coming out of the 2 tanks and coming up into the weir tank. Now looking over into the piping, you can see the under drain piping, which collects the filtered water, and the harrowing valve. And then coming back over the top, we're going to see the piezometer tubes and the sight tubes, which is how you know when to clean the filter. And the 2 clear tubes will tell you the difference in water height, and those 2 tubes tells you what's going on with the filter when you need to clean it. We supply solutions that can be operated by somebody or a community long term without ever buying another thing from us. But we figure that the world's a really big place. There's billions of people and there's millions of people that don't have water. So I think we've got a pretty unlimited market.